Hello everyone. In the previous session of hashing, we have seen what is the concept of hashing, what is hash map, operations involved in a hash map, and we have seen how a particular hash map is implemented internally in my compiler. Now I have said you that in maps we have three types: hash map, linked map, tree map. Similarly in sets again we have three types: hash set, linked set, tree set. Now let us talk about each one of them in detail. So talking about a linked map, linked hash map, a linked hash map is nothing but linked hash map follows the same properties of hash map, but the only difference is that the keys are inserted in ordered fashion, right? And if you remember, in the hash map I have shown you that in the previous example I have inserted countries and their population using hash map, and when I printed those output in the hash map, you can see that I got the output randomly. So if I want my insertion to be in a particular order, then I will use linked hash map. Now you can ask, what is going on internally at implementation level? What is the change? How a particular linked hash map is different from a general hash map. So to understand the implementation is very same as hash map implementation. We use arrays of linked list concept, but if you see the diagram of hash map, at that point we use a singly linked list. The direction is a unidirection. We are going in a single direction in hash map, whereas in linked hash map the implementation happens using doubly linked list. So using doubly linked list, implementation will happen, and because of this doubly linked list, the inserted keys are in ordered fashion. Right? I hope you have understood. This is the only difference, and the operations, whatever the time complexity that will take to perform those operations will remain the same. It means that for all the operation, for put, for get, for remove, for is empty, size, for all these operations, the time complexity for linked hash map will be big of 1, and it is as same as a general hash map, but the only difference between a hash map and a linked hash map is, in linked hash map the implementation at implementation level, the implementation happens using doubly linked list, whereas in general hash map the implementation happens using a singly linked list. This is the only difference. Now if I want to create a linked hash map in my Java program, then what I will do is that first of all I will write linked hash map. After it I will write my key data type, after it my value data type. Now after it my name, whatever the linked hash map I am creating, LHM is equals to new linked hash map, right? This is how I will create. So the only difference you need to keep in mind is that hash map is implemented using arrays of linked list, and in that we use single linked list, whereas in linked hash map the implementation happens with the same concept of arrays of linked list, but here we use a doubly linked list concept, and because of using the doubly linked list, the keys are inserted in a ordered fashion. This is the only difference. Now let us code this thing. Okay, so here I have imported my Java package, import java.util.star. After it I have created my class, public class. HashMap is my file name, so I have created my old universal class. After it my main function, and in the main function what I'm gonna do is that I will implement first of all HashMap, because I wanna show you the difference between a general hash map and a linked hash map. So first of all, here let me take the same example, insertion of countries and their population. So integer and hm is equals to new hash map. Now here I'm gonna insert hm dot put. Here it is showing some kind of error. What's the error? Okay, so let me give a class name a little bit different, my hash map, because this is getting a little bit confused now. So I have changed my file name. My file name is my hash map. After that I have created hash map in my main function. After that I am putting hm.put. Let me put India as my country name and population as 150. You might get a little bored that why I am using always countries and their populations, why we are not doing questions. I will do questions in a little bit in a while, but to get a easy understanding, I'm using the basic example, countries and their population in a tabular form. That is why I'm using it. Okay. After that, let me put hm.put USA and their population 150. Let me give the same value. After that, hm.put UK and its country's population, let's say 100. Okay, so I have inserted. After that, I'm printing my hash map. Let me print my hash map. Now after that, I will create my linked hash map. So I'm gonna create my linked hash map, and the same thing, string and integer linked hash map is equals to new linked hash map. Now after that, I'm gonna insert in the linked hash map, I'm gonna add elements. So hm.add, and I will write India. I'm gonna insert the same thing in my linked hash map, but I will show you what is the difference between a general hash map and a linked hash map. So India and its value as 150. Now after that, again lm.put, I'm gonna insert USA. Now after that, let me put the same value 150. After that, lhm.put UK. Now let me give 20. Okay. Now after that, I'm gonna print system.out.print my LHM. Okay. So if I run this code, you can see that HM, that is my hash map, is an unordered structure. So it will store my given inserted data randomly. Now if you observe the output, I'm gonna run the output, but if you see, the output is in structured format. My insertion will happen in a structured format. Now let me save and run this. So first of all, it is showing some kind of error. Okay, this is just warning, so you can ignore the warning. Now if you see the output, you can see that first of all, I have inserted in the hash map, I have inserted first India, after US, after UK. Now if you observe that, first of all, I am getting in the hash map, I am getting some random values. Now if you observe the linked hash map output, you can see that I am getting in what order I have inserted, I am getting in the same order in my output screen. So this is the difference. This is the only difference between a general hash map and a linked hash map, and all the operations will remain the same. I can get a particular element by writing .get. I can remove a particular element by writing .remove. I can check whether the hash map is empty or not. I can get the size. I can clear if I wanna clear all the hash map, whatever the elements present in my linked hash map. If I wanna clear them, then I will write lhm.clear. So this function will delete my whole linked hash map. So the operations will remain the same. The operations which we are using will remain the same, but the only difference is that insertion will happen in a structured format. Okay. Now let us talk about TreeMap. TreeMap, the only difference between a TreeMap and a linked hash map and a general hash map is that the keys, when you insert, the insertion will happen in a structured format, and that structured format follows a priority, and that priority is keys. That priority is nothing but keys. So let's say I am inserting India, UK and Zimbabwe, right? So when I insert, the insertion will happen, let's say I am creating a tree map and I am inserting India, USA and finally Zimbabwe. So when I insert these three countries, the insertion will happen based on the key order. Let's say the first letter which is coming is I. So the insertion of India will happen first, after US, after UK. Right? So based on the keys, my whole tree map will get sorted. And one more thing you need to remember here is that the time complexity of performing operations in a tree map will be big of log n. Okay, the time complexity will be big of log n, and you might ask why the time complexity is increasing. Because tree map uses a concept of red black tree. So this uses a concept of the implementation internally happens based on the concept of red black tree, and this red black tree concept, because of this concept, the time complexity increases quite slightly. It increases a little bit. Okay, so this is about a tree map. And the implementation, the creation of tree map will be, first of all I will write tree map, and after that I will give my key data type, after that I will give my value data type, after that my tree map value name is equals to new tree map. Like that, like this I can create my tree map into my Java program. Okay, and the internal implementation happens based on the concept of red black tree, and red black tree is as same as AVL trees, right? So red black tree is also self-balancing tree in nature, and I will provide you the material of red black tree in the description. But you know, if you understand the concept of AVL trees, you can understand the concept of red black tree. Okay, so because of internal implementation happens based on this concept, the time complexity of tree map gets increases. And the property you need to remember when you hear the name tree map is keys are sorted in ascending order. Keys are basically sorted, and insertion will also happen based on key priority. So I will show you what the meaning of priority is. So let me show you the code. So here, first of all, let's say that I'm creating a tree map. Let me delete this. Okay, so here I'm creating a tree map, and here I will take the same example, string, after that my integer tree map is equals to new tree map, right? After this I'm adding in my tree map, let's say I'm adding new elements. Okay, so here first of all I'm adding India, and India population as 100. After that here tree map dot put, I'm adding something, let's say that a country starting with a C, a letter prior than I, so China, and their population as 200. After that here let me add tm dot put, and here let's say I'm adding USA, and USA population is 100. After that I'm adding tm dot put Zimbabwe, or let's say a country starting with Z. Now after that I'm adding 100. Okay, their population as 100. Now if I print the output, if I print this tree map, then my output will be based on the keys. So the key which comes first based on the indexing, let's say in this C comes first, right? So China will get inserted, and in my output I will get China first. After that I will come, after that U will come, after that Z will come. So based on this key priority, my keys will get sorted, and I will get output based on this sorted fashion. Now let me remove all these things. Let me remove my HashMap and tree map, and let me save and run this code. So if I run this code, you can see that my output is, first of all I am getting China, after that I am getting India, after that I am getting USA, after that I am getting Zimbabwe. Like this my keys will get sorted based on the keys priority. If I am, let's say in the place of string, let's say my key data type is integer, then the integer which comes first, for example I am adding 10, 20, 30, in my keys I am adding 10, 20 and 0. Okay, so the 0th element will come first, because the sorting will take place based on keys. Here I am getting China because C will come first, in characters C will come first, that is why I am getting China. So after that I am getting India, after that I am getting USA, after that I am getting Zimbabwe. Let's say I am adding Zimbabwe first. Let's say that I am adding Zimbabwe first. Before China, I am adding Zimbabwe. Now if I run the code, I will get the same output. I will get the China, I will get the India, after that I will get USA, after that Zimbabwe. Like this I will get the output, irrespective of what is getting added first, what is getting added last, irrespective of all that. Based on the sorted fashion of keys, I will get my output. So this is the difference between a hash map, a linked hash map, and a tree map. And one more thing is that you need to remember is that for hash map, the time complexity will be big of 1, and for linked hash map the time complexity will be big of 1. So for this, the linked hash map and the general hash map, the time complexity remains the same. Okay, but when it comes to tree map, the time complexity for this will become, become log n, because internally tree map implementation happens in the form of red black tree. Okay, this is the basic difference between a hash map linked hash map and a tree map, and the operations will remain the same, but the only change is implementation and time complexity. That's all. So I hope you have understood these three different data structures in map. Now let us do some questions. So the name of the question is majority elements. So user will give me an array and I need to print the elements of an array which has occurred more than n by 3 times. Here the n is the size of the array. For example, to understand this question, let us consider this array and I will count the occurrence of each character. For example, here you can see that 1 has occurred 1, 2, 3, 4 times. So 1 has occurred 4 times. 3, the element 3 has occurred 1, 2. So 3 has occurred 2 times. After the element 2 has occurred only 1 time. So 2 has occurred 1 time. After 5, the element 5 has occurred 1, 2. So the element 5 has occurred 2 times. Now the size of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size of n is 9 and n by 3 will be 3. So I need to print an element which has occurred more than 3 times. You can see that in this, the whole occurrence of different elements, only there is one element, that is 1, has occurred more than 3 times. So if it has occurred more than 3 times, then I will print that particular element in my output screen. So this is the basic asking of my question. Okay, so I hope you have understood the overall asking of the question. Now if you think of brute force, you know, I will create, if I am talking about the brute force, let's say I don't know the concept of hash map. So if I talk about the brute force, what I will do, I will create a new array. I will create a new array and I will take the occurrence of each character. I will create one, how many elements we are having? We are having 4 elements. So 1, 2, 3, 4, 5, and I will store the occurrence of each element. 1 has occurred 4 times, after 2 has occurred 1 times, after 3 has occurred 2 times, 4 has occurred 0 times, after 5 has occurred 2 times. So here, talking about the brute force, I will create a new array and I will take the least element, I will take the max element, and I will create the size of a new array will be the size of my new the total number of elements in my new array will be maximum elements. Let's say I am having 5 elements, so I will create 5 elements and at each index I will store the occurrence, and after it I will run a loop and I will check whether the particular occurrence of that character, whether the particular occurrence of that element is greater than n by 3 or not. If it is greater than n by 3, then I will print it, else I will not print it. So the time complexity will be aroundly, if you say generally, the time complexity of brute force will be big of n square. Now what I'm gonna do is that first of all I will create, I know hash map and I will use the concepts of hash map. So I will not use brute force here. I will use the concept of hash map and I will make my code efficient. So what I will do is that I will create a hash map. The first step will be create a hash map, and after creating hash map, you know, this is my key. On the key side I will store elements and on the value side I will store the frequency of that element. Okay, so after that I will run a loop. The second step will be run a loop of my array. In my array I will run a loop. Okay, now I will check if that particular element present in my hash map or not. If that particular element is present in my hash map, if it is present, then I will have a corresponding value. So I will increment the value by 1. So I will increment value, whatever the value I am having. If it is existing, if it is already existing in my hash map, then I will increment that value by 1. Else, if it is not existing in my hash map, then I will put value is equals to 1. So this is what I am doing. So I am creating a hash map. On the left side I am storing elements. On the right side I am storing their frequency. Okay, so here let me erase this thing. Okay, let me erase this. Okay, now here what I will do is that I will run a loop. First of all I will come to 1. You can see that initially my hash map is empty. So if it is empty, if this particular one element is not present in my hash map, then I will add that element and I will put its corresponding value as 1. Okay, so I will add 1 and I will put its value as 1. Now after that I will go to 3. 3 is not present in my hash map, so I will add 3 and its occurrence will be 1. After that I will go to 2. 2 is not present, so 2 and its occurrence is 1. After that 5 is also not here, so I will add 5. After that I will put its occurrence 1. Now I will come to here. This particular element, this particular key is already present. If it is already present, then I will increment the value. So I will make it from 1 to 2. After 3, I will go to the next element, that is 3. 3 is already present, so increment its value. After that again 1, so I increment from 2 to my key value will become 3. After that 5 is already present, so increment 2. After that again the last element is 1, so increment like this. Now after incrementing, my new hash map will look something like this. So 1 occurrence is 4, after 3 occurrence is 2, after 2 occurrence is 1, after 5 occurrence is 2. So this is my new hash map. After performing all the operations, my new hash map will become like this. Now the third step will be run a loop in your hash map. Run a loop and check if particular key's value is greater than n by 3. If this is the case, then print that particular element, right? Print that particular element. This is what I will do. This is the overall approach of my code. Okay, so I hope you have understood the approach of my question. So here I will run a loop. First of all, I will come to this key. You can see that its occurrence is 4 and n by 3 is 3. So you can see that here this condition is satisfying. If my key's value is greater than n by 3, greater than or equals to n by 3, then I will print. So let's say this is my output screen. So here I will print 1. After that I will go to next. So here you can see that 2 is not greater than 3. Okay, I will move to next element. Again 2 is not greater than 3. I will move to next element. Like this I will iterate and I will check. So I hope you have understood the overall working. So for the given array, the first step is create a new hash map. Second step is iterate through each and every index of your hash map, and as you iterate, what you will do is that you will keep a track of frequency of each element. Okay, now after calculating the whole element, the whole array, what you will do is that you will move to the third step. The third step is run a loop and check whether the frequency of that particular element is greater than n by 3. If it is the case, then print that element. If it is not the case, then don't print the element. This is the basic approach. Now can we code this? Let us code this thing. Okay, so the step 1 is create hash map. So first of all I will create hash map of integer, because on the left column I am storing integer, on the right column I am storing the integer. So integer, the key data type will be integer and the value data type will also be integer. Integer comma integer, hm is equals to new hash map. Now after that what I will do is that I need to run a loop and I need to check each element whether that particular element is present in my hash map or not. So I will run a loop for int I is equals to 0 and I should be less than arr dot length after I plus plus. In this I will check if my hm dot contains this particular key. What is the key? ARR of ith element. If this particular element already exists in my hash map, then I need to increment the value, whatever the corresponding value this key is storing, I need to increment it. So what I will do is that I will write hm dot put and I will write ARR of I comma I need to increment its value. So I just have to write hm dot get. I will get whatever the value I am storing, existing value in my hash map ARR of I, plus I will need to increment it by 1. So I will increment this thing plus 1. Like this I will increment. So what I am doing is that if a particular key already exists in my hash map, then I am incrementing its corresponding value by 1. Okay, if it doesn't exist, then what I have to do is that I will come to in my else step after hm dot put and ARR of I, and I will put its value as 1. This is what I am doing. So this is my step 2. So this will be my step 2 here. Let me write it. This is my step 2. Now the step 3 will be I need to check whether the corresponding key value pair is having a value which is greater than n by 3. So in the step 3, first of all, I will store whatever the keys I am having. By creating a step, I know that how I can iterate. I have already shown you that how we can iterate my hash map by creating a set of integer. Let's say that I'm creating key, and this set will store the key values is equals to hm dot key set. So I will get the key set, whatever my hash map is storing keys, I will store that in a key variable. Now I need to, in order to iterate my hash map, I'm gonna use a for each loop. So integer of integer, and this is the key. So let me give I here as my iterator. After that, I will print if my map hm dot get key values, if my I value is greater than n by 3, that is here n is int n is equals to arr dot length. So if this is the case, then I will print that particular element. So whatever the value I'm having, I will print it. So system.out.print, I will print that particular key value. That's all. This is what I'm gonna do. Now let me save this program. So if I run this program, then I will get the output as 1, because I'm in this, you can see that I'm only having a element which has occurred more than 3 times. Okay, so this is what my output will be. 1 will be my output. Now let me save and run. So you can see that I got the output 1, because in the given array my 1 has occurred more than 3 times. There is no other elements which has occurred more than 1 time. So that is why I will get my output as 1. So I hope you have understood the 3 steps which we are doing. In the step 1, I have created my hash map. After that, in the step 2, I am adding elements into my hash map based on the frequency, or you can say occurrence of each element in my array. After that, in the step 3, I am using a for each loop, and by using the for each loop, I am checking whether for a particular key, whether its occurrence is more than 3 or not. If its occurrence is more than 3, then and only I am printing that element, else I am not printing. Okay, this is the basic approach. Now let us talk about another interesting question. The name of the question is valid anagrams. So in the question, user will give me a 2 strings. Let's say the 2 strings are s and t, and we need to return a particular value. If s and t are anagrams, then I need to return true, else I will return false. So what is anagram? Anagram, let's say I'm having s is equals to a t, right, and t is equals to t a. You can see that if a particular given 2 strings is said to be an anagram if it follows 2 conditions. What are the 2 conditions? The first condition is if the size of t and s and t are same, and the second condition is if the characters used in these 2 strings are also same. You can see that here I am using a after t, here also I am using a and t. So if the characters which are being used in the 2 strings, if the characters are also same, if I am satisfying these 2 conditions, then that particular given 2 strings is said to be an anagram. Okay, I hope you have understood, right? For example, let's say that I am taking a string yes. Here I am taking a string s is equals to race and t is equals to care. So the given 2 strings, first of all, their sizes are same. Okay, and the characters which I am using in s string, I am using the same characters, but basically I am changing the sequence of them, sequence of the string, that's all. So if this is the case, then that particular given s and t strings will become anagrams, valid anagrams, else it will not become a valid anagram. So if it is a valid anagram, then I will return true. If it is not a valid anagram, you can see that in that third example, here you can see TULIP. Okay, so the size of this will be 1 2 3 4 5. The size of this is 5, and the size of t is also 1 2 3 4 5. But here there is an extra character which is not present in my s string. Because of this will not become a valid anagram. So if it is not a valid anagram, I will return false. Okay, so an anagram is a word or phrase formed by rearranging of letters of different words. So rearrangement will happen, and if all the characters which are being used in the first string is repeating in the second string irrespective of the order, if this is the case, then it will become a valid anagram. I hope you have understood what is a valid anagram, what is a invalid anagram. Okay, now let us talk about the approach of this question, how we are going to solve this question. So talking about the approach, first of all, I will create a hash map. Here we are making our code efficient and we are going to use the concept of hash map. Okay, so first of all I will create a hash map and I will iterate. First of all I will iterate. The second step will be I will iterate through my S string and I will count the frequency of each character. So what I will do is that here let's say this is my hash map. So initially my hash map is empty. Now I will iterate through each and every index. So initially I will on the key side I will store characters, on the value side I will store their occurrence. Okay, so first of all I will come to k. K is not present in my hash map. So what I will do is that I will add k and its occurrence is 1. After that I will add n. I will come to the next element n and its occurrence is 1. After that I will come to e and its occurrence is 1. After that again the next element is also e. So I will just basically update the value as occurrence as 2. So this is what I will do. This is my step 3. Now in the step 3 what I will do is that I will iterate the t string, and as I iterate through each and every character I will decrement the count. I will decrement the count of my hash map. Okay, so what I mean by decrement is that let's say this is my k, right? So I will come to first of all k, and as I come I will remove or decrement the value of that particular key. I will decrement its value. So here you can see that my key value is k. So for k I will decrement its occurrence. Here the occurrence is 1, so I will decrement it by 1. So I will make it 1 minus 1, that is 0. So the occurrence will become 0. Okay, so if the occurrence becomes 0, if the value by decrementing I am decrementing, if the value becomes 0, then if the value becomes for a particular key its value becomes 0, then I will immediately remove that particular element. I will remove that particular key from my hash map. So here you can see that for k its value is 0. So first of all I will remove it. Now I will come to e. So e occurrences, initially I will make a hash map. This is becoming something messy. So after the second loop my hash map will become like this, n1 after e2. So let me remove this. I will tell you again the step 3 what I am doing in the step 3. So here in the step 3 what I am doing is that I am running a loop, and as I run I will go to the corresponding key for that particular character. If the character is existing in my hash map, then I will decrement the corresponding key value. So here you can see that first of all I will come to k. So I will check whether this particular k is present in my hash map or not. If it is not present, I am checking that whether the particular character is present or not. If it is not present, if the answer is no, if this particular character is not present in my hash map, if this is the case, then immediately return false, because I am having a new character which is not present in my hash map. If this is the case, then it will not become a valid anagram. So I will immediately return false. If the case is yes, then I will go to this step. Okay, so I will decrement its occurrence by 1, and if the value becomes 0, then I will remove the particular key value pair from my hash map. After that I will come to e. So e occurrence is 2, so I will decrement it by 1. After that again I will iterate through the next character, and again the next character is e. So the occurrence of e will become 0. If it is 0, so then I will remove e from my hash map. After that I will come to n. N occurrence is also 0. So n occurrence is 1, so I will decrement it by 1, and if the occurrence is 0, then I will remove the key value pair from my hash map. Now you can observe that after deleting all the elements, my hash map is empty. If my hash map is empty, if it is empty, then I will return true. If it is not empty, there is still some elements left, then I will return false. This is the basic approach. Okay, so what I'm doing is that to calculate whether the given two strings is anagram or not, in order to calculate, first of all I'm creating a hash map. Okay, after it I'm iterating for the given first string, I'm iterating, and as I iterate I am incrementing the occurrence, I'm calculating the frequency of each character. Okay, now after calculating the frequency of each character, I will get a new hash map. I will get a you can say final hash map. Okay, and after it, after performing the second step, I am coming to my step 3. In the step 3, again I am running a loop for the second string, for my t string, and as I iterate I am checking whether this particular character exists in my hash map or not. If it exists, then I will decrement its occurrence by 1, and I will keep on decrementing the occurrence of that particular character until the occurrence becomes 0. If the occurrence of that particular character becomes 0, then I will remove that key value pair from my hash map. Okay, and finally after all the iteration process, if my hash map is empty, then I will return false, I will return true. If there is some elements present, it means that there is in S string there are some elements which is not present in my T string. This is the indirect meaning of it. So if this is the case, then I will return false. I hope you have understood the overall approach. If you didn't, then rewind and see the video again. Okay, now let us code this thing. So first of all, let me create a function, public static boolean type function, because I am returning whether it is a anagram or not. So is anagram. Here my user will pass me two strings, a string, yes, after that string t. Now what is my first step? Step 1 will be create a hash map. So first of all I will create hash map of string and character, because I am storing character, right? So character and its occurrence. So occurrence will be basically an integer. So I will store integer, right? Integer, and hm is equals to new hash map. Now after it, what I will do is that I need to run my loop. For my step 2 will be run a loop. Step 2 will be run a loop for s string. So for int I is equals to 0 and I should be less than s dot caret s dot size s dot length. Okay, now after that I plus plus. In this, what I will do is that I will store each and every character. So character char ch is equals to s dot caret particular ith index. Now I need to check whether this particular character is present in my hash map or not. So to check whether a particular key is present or not, I will write if this particular key. Now after creating character, I need to add my this particular character into my hash map. Now you can see that in the previous code here, you can see I have checked whether this particular character, this particular array element is present in my hash map or not. Like this I am checking. Now I am gonna use a shortcut. In one liner I am gonna write whether a particular hash map is key is present in my hash map or not. So I am gonna write a shortcut method. So I will write hm dot put, I will write ch after hm dot put hm dot get or default. So what this will do is that if my particular character is present in my hash map, then I will increment its count by 1. I will increment its count by 1. Okay, that's all. So if it is not present, what this hm dot get or put hm dot get or default function will do is that it will check whether the given character is present or not. If it is not present, then it will assign 0. If it is present, then it will increment it by 1. So instead of writing this whole thing, this 4 lines, I'm checking the same condition by this one line. Okay, now after checking I'm incrementing by 1. This is what I'm doing in my step 2. Now in the step 3, I need to check whether the key on the t on the second string, I will iterate each and every index, and I will increment the occurrence of that particular character in my hash map. So I will run a loop for int I is equals to 0 and I should be less than t dot length after I plus plus. In this, what I will do is that I will check the occurrence of this character in my hash map. So if char ch is equals to t dot caret that particular ith element, now after that, if hm dot get this character is not null, it means that its occurrence is not null, then what I will do is that I will check whether its occurrence is 1 or not. hm dot get, if its occurrence is 1, then I will decrement it by 1 and remove it. Okay, so here I will write ch is equals to 1. If this occurrence, if for a particular character it has occurrence 1, then I will remove that particular character from my hash map. So hm dot remove that particular ch character. Else what I will do is decrement it by 1. So else hm dot put this ch comma hm dot get whatever the occurrence it is having, this particular character is having, take that occurrence and decrement it by 1. This is what I am doing. Now if this is not the case, if I am getting a new character which is not present in my hash map, let's say here you can see that here you can see I am getting lipid, here I am getting D which is not present in my hash map. So what I will do is that if this is the case, then I will immediately return false, Now in the function, if all the operations has performed and finally I am coming to the end of the statement, end of the function, then if my hash map is empty, then I will return true. If it is not empty, I will return false. So I am checking if my hm dot is size is empty. If this is true, then I will return true. If this is false, then I will return false. Okay, now let me remove all this and I will take the example which we have taken in the dry run. Now you can see that these two are anagrams. Now if I call system.out.print is anagram function and I will pass s and t, then this should return me true. This program should return me true. Okay, now let me save this and run. So you can see that I got the output as true. Let's say in the place of yes, I am passing something new character like this. Now let me save and run. So if you can see that here yes and t are not anagrams. If they are not anagrams, it should return me false. Like this, I will check whether the two characters is anagram or not. Right? I hope you have understood the overall approach, what I am doing. Now in the next lecture, we will see what is a set, what are the 3 different types of set, and we will solve some questions based on the concept of set. With that being said, I will see you in the third part of hashing.